So guys, here we are back with another video, and today we will be discussing about a question paper which is of 6th August 2023. Why this particular paper? Because this paper was a little bit complex, logic based as well as theory based. So you will get a mix of everything. So we will look at how to solve this particular question paper by looking at the required theory, applying the logic, as well as looking at the solution. In midst, I may give you some tips, so keep a lookout on that. All the resources will be provided in the description. So with this, let's start today's session. So let's head to our questions. Simple way is just to do a simple search, and obviously you will get the paper itself. So our first question is question number 175, and the question says consider the following code and its output code. First one is sklearn.dataset import load diaries, and then we have a linear model called logistic regression. Then we will load our data. Return xy is equal to true means that we will get this particular tuple where x will be nothing but our feature matrix and y will be nothing but our labels. Okay, after that we will create an instance of logistic regression in the variable CLF and set the random state to 0, and then we will directly fit x and y. So that means we are fitting the features as well as labels, and labels basically means your target. Okay, now if you see here, it is saying that print y 70 to 80. So y was what? It was our test labels, right? Or train labels, you can say whatever you want. And clf.predict x of 70 to 80, all the values in the columns, right? And 70 to 80 rows only. Okay, so this is rows and this is columns. Okay, so it will predict, and here we are given output. This is our input and this is our output, right? Now the question asks that what will be the output of the following code, and the code is print clf.score x 70 to 80 y 70 to 80. Now it says score, so just know one thing, that any classifier by default, if nothing is imported, the score will be accuracy. So accuracy is nothing but number of correct divided by total number of samples. So by number we can denote it like, so how many are there which are correct? So for correct we have to check our actual value and predicted value should match, right? So 1 2 3 4 5 6 7 8. So 8 is total, and total number of samples are 8 plus 2 10, right? So these are correct, these are wrong, so it's 8 by 10, so that will give you 0.8. so this is the default value. But if this was a regressor, right, so in that case the score, if nothing is imported, by default this score will be nothing but our R2 score. Okay, so keep that in mind. This is a small theory that you need to know. So this marks the completion of this question. Let's check if whether our answer is right or wrong. So you can see that we have our 0.8 as right. So now let's move on to our next question. So our next question is question number 176, and it says what might be the possible output for the following code. From sklearn.matrix import precision score. This is our truth, this is our predicted value, and we have to get the precision score. So precision score refers to how precise your particular model is predicting y true and y pred. But whenever I see these type of questions, I first create a confusion matrix, and you can see this is a binary class problem, right? So we can create a confusion matrix in a row wise mirror such that this side will be our predicted and this side will be our actual. And what are the actual values and predicted values? These are 0 and 1. So make sure that you also follow this particular thing. Okay, so how many values are where 0 and 0 is there? 1 2 3 and 5, right? So 4. After that, how many values are there where 0 is actual and 1 is the predicted value? So it is 0, right? There is none such value. How many values are there where 1 is actual and 0 is the predicted value? So 1 0 1 0, it means 2. And how many are there which have 1 as actual and 1 as predicted? 1 2 and 3, right? So this is our base class, and we know that precision is equal to true positive divided by true positive plus false positive. And if you don't know what these terms mean, so this means y also true and predicted also true, same thing here. And this means that y is equal to not true and predicted is true. And by default, if you see in this particular confusion matrix, if you do it in this manner, this will be your true negative, this will be your true positive, this will be your false positive, and this will be your false negative. So we just need to add them up. So what are the values which we need to add up? It is true positive, that is 3, and what is our true positive? 3 plus what is false positive? 0. So 3 by 3 is equal. Similarly, you also have something called recall. So for recall also I am writing the formula. You can refer to any documentation for better understanding. That is true positive by true positive plus false negative. So all you need to do is this, that your actual is 1 and your predicted value is 0. But this is only for binary case, and if you create this particular confusion matrix in this particular manner, if you change the order, that is actual goes here and predicted goes here, then this particular order will change. You can check it accordingly to your liking. And now let's check whether our answer is right. So answer is 1, right? So this marks the completion of this particular question. Now let's move on to the next question. Now for the next two questions, I will be mostly skipping them because these two questions are part of our previous video. So you can refer to that. Now we are on our fifth question, which is question number 179, and it simply asks for what parameter C in logistic regression does. So in particular, your logistic regression has this logistic function which actually maps our equation of W1 x1 plus W2 x2 plus W3 x3 up to Wn xn plus b to some sort of probability. Now these W1, W2, W3, Wn, all these are part of our input, right? And these are nothing but called weight. Now what happens if the weights are small, model converges very good. But if weight is very large, say like 10,000 for W1 and W2 is 300, then in that case model will give preference to W1 as it is giving more and more importance in some sense, because ultimately this W1 is getting multiplied with this. So in that case our model becomes biased. So to handle those things we use something called regularization, and this C act as a regularization. Okay, and the way it does it is it uses some threshold called alpha so that you can map those weights to smaller values. Let me show you something. Like say my alpha is 5 and my W1 is 10,000. Okay, now if I divide by 5, so this will be 2,000, right? So you can see that our weights had been reduced. Obviously this is our own choice, but yes, you can see that these values are now little bit closer compared to 10,000, right? So in that case it works in that way. So always remember this particular theory, that C is equal to 1 by alpha, and alpha is the threshold value, and threshold value we use just in our denominator to make this scaled, right? So same question it is asking, what is the parameter C in logistic regression? So you can see that it is similar to 1 by alpha, where alpha is parameter of the ridge regressor, where alpha is nothing but our threshold. Let me know if I am missing some implementation details in the comments. Okay, so this marks the solution to this particular question. Now let's move on to next. So our next question is question number 6, which is question number 180, and it simply says your task is to design a model that predict label of an article in order to help an online news website. The label could be political, sports, and international. Following the label matrix of random 3 articles, what type of classification problem is this? Now if you see here how many labels we have 3 labels, right? 3 different labels, right? So this makes it multi-label. Now for each label, how many classes we can predict? For this one we are only predicting one particular, but for this how many classes we are predicting? 2, and this again 1. So that means that this particular fact that these 2 are getting predicted at the same time, if you use type of classification method which is present in the sklearn library, you will simply get multi-label multi-class classification problem, and that's what they are asking. So if we scroll down a little bit, you can see that it's called multi-class multi-label classification problem. Obviously I just switched the terms, but they all both means almost same. Okay, now this marks the completion of this particular question. Now let's move on to our next question. Now we are on our question number 7, which is question number 181, and it simply says, how does strong correlation between features given the labels impact the classification performance of naive Bayes? So the key term to solve this particular question is looking for what are the important things that are being told. So first important thing is that it has a very strong correlation between features and also that given label. So naive Bayes assumes that your features are independent. However, when you say strong correlation, it simply means one variable prediction can influence the another variable prediction, right? And this is not the case where naive Bayes works the best, because strong correlation makes it a dependent feature. So in that particular case, naive Bayes fails. So this is what they ask, what it will make the impact on the naive Bayes. So as you will have a strong correlation, your performance will down. So this is kind of reasoning you can find. And also when you see naive Bayes or any Bayes, just remember Bayes theorem. Obviously you can look into the implementation details later on, but just remember that Bayes theorem assumes this particular conditional independence because it makes things much simpler to deal with. Okay, so let's check whether our answer is right or wrong. So you can see that it has no impact because naive Bayes assumes features independence. Doesn't matter because your data is directly says that it has a strong correlation, so it will impact, right? Improves classification performance? No, it degrades actually. So it degrades the classification problem. It depends on type of naive Bayes variant used. No, all naive Bayes algorithm variant will has this particular assumption which is getting falsified due to this strong correlation fact. Okay, so this marks the completion of this particular question. Let's move on to the next. Our next question is question number 180, and it asks for when might be precision recall curve be more informative than ROC curve. So precision and recall are metrics for classification, while ROC curve is a comparison of precision and recall. So if you see, precision recall works best when you have unbalanced data. So at this particular year you have multiple instances, multiple values for precision, multiple values for recall. Okay, and you will have a plot, say this, something like that, right? So in this particular case you can see that for a small value of recall precision, small value of recall, you have very high precision, so that means you are going good. Your aim should be always to be above this particular line. Maybe something here is a good. So this is what actually precision recall does, and this straight line is nothing but our baseline, which simply gives us the baseline prediction, and we try to improve overall from. Okay, while on the other hand, precision and recall curve give you a more deterministic approach to understanding what your particular data is. And to be very frank, I don't look at even this curve. I just know that precision and recall is for classification and it works best with unbalanced data because most of the time we use it in confusion matrix. So confusion matrix helps us in TP, TN, TP, FP, FN. So you know this, right? You already saw this in the earlier question. So from there only I directly derived this particular thing, but base idea is this only, right? So here it simply means that when data set is imbalanced, you will have a bad precision and recall. It will be important to understand whether our class 0 is doing good or class 1 is doing good. So based on that you will do much better. Okay, and while data set is equal number of positive and negative instances, in that particular case your ROC and precision recall both works fine because that doesn't matter. Anyhow, when classifier has high accuracy, it doesn't mean, because precision and recall don't look at the individual accuracy, they look at the positive and negative cases. Okay, so this is wrong. When the classifier produces balanced precision and recall scores, this itself means that you have equal number of positive and negative cases in some sense. Okay, so this marks the end of this particular question. Now let's move on to our next question. So our next question is question number 183, and here we have our data which says that ordinal data of sizes cups used in coffee shop. Which of the following code will correctly transform the data set as the given in the output array? So you have this particular data set, basically labels, and you have the output, and you can see that these particular strings are mapped to numbers using ordinal encoder because it encodes in an order. So by default, ordinal encoder works in dictionary way or alphabetical way. So in that particular case, this 0 small will not be there. It will in fact come at the very last, but it is not the case here. We have an order, right? So that for that we have have categories parameter which takes in a 2D array where this array will be nothing but the classes like small, medium and large. Okay, so in this particular order it will encode. So let's check whether our implementations are right or wrong. So first one directly fails off because it has not used the class, right? So wrong. The second one uses the classes and it's a 2D array, so yes, it's right, and it uses the categories also. Okay. Third one again same issue, so wrong. Also second issue is that here we didn't use fit underscore transform. If we are using one time, then you have to use fit underscore transform. And last one is this is not the right way to use the categories parameter, or even if you are directly passing, you have to pass it as a 2D array, not as a dictionary. Okay, so this marks the completion of this particular question. Now let's move to our next question. Now we are in our question number 184, and it asks which of the following parameters are learned by the k nearest neighbors or k neighbors regression model while training. So here two keywords are important: parameters learned and while training. So there are few parameters which are given here. So this is an attribute, this is a parameter, but the fact is that in KNN model doesn't learn anything. It just uses distance as a metric and n neighbors to classify whether a point is in that particular class or not, right? So in that particular sense, model is learning nothing. So all these options which are given here are wrong. But one might argue that we are actually learning n neighbors and also coefficient. So coefficient we are not learning first of all, and n neighbors you are putting it, right? Even if you are doing grid search that you usually do to tune the hyperparameters, you are not actually learning it, you are just finding the right fit, and it is you who will be providing this best parameter value to the model. It is not learned by the model itself, right? So in that particular sense, none of these is right. So this marks the completion of this particular question. Now let's move on to the next question. Now guys, we are in our question number 185, and this particular question is really a very good question. I don't know whether it is important or not, but this actually lets you think a lot while solving this particular question, because this is from the core ML concept directly of the SVM. Your xi is an input instance with label yi. So you have this particular pair xi comma yi, and additionally this xi is the support vector. What will output of this formula? So this formula is given, right? And w1 and w are estimated parameters for the model, so you don't need to worry about this. Okay, by the way, this is bias and this is the weight that is giving the importance to this particular thing. So for this I'm just going to explain you what SVM actually does, and then we will look at whether our assumptions are right or wrong. Okay, so in our SVM we have a base decision boundary which is w transpose x is equal to 0, which is just nothing but a matrix of x1 x2 x3 and w1 w2 and w3, and that's get multiplied and added, but here we are using w to represent w1 w2 w3 and x as x1 x2 x3. Okay, so this is directly from the core ML concept. And now just to give an edge to the model, we are creating two decision boundary. This is for the positive class, so we will have w transpose x is equal to 1 and we have w transpose x is equal to minus. So any point which is behind w transpose x minus 1 will be negative. Okay, these. On the other hand, if a point is behind w transpose x is equal to 1 line, then it will be a positive, but there might be few conditions, right? So in that case you need to be very peculiar. Some points may lie on this particular line, right? And the points which lie on this particular line are called support vectors. Similarly here also the point will lie on the line. These are also called support vectors. And the property for this is that for any point on this particular line, if you do, you will have w transpose x as either minus 1 or plus 1, and you also have your y labels in the hand right now, right? You have this y label, so it simply asks that if you do this times your yi, which is either plus 1 or minus 1, what you will be getting. So just take some value, let's say this is plus 1 for our cases and this is minus 1 for our case. So first case we are going to use for yi as 1. Okay, so yi will be 1. So in that case 1 into w transpose x, and this w transpose x has the property that it will give you 1 because it's on this particular line itself. If it has been either here, then this particular line would be w transpose x less than 0. On the other hand, this would be w transpose x is greater than 0. Okay, so here we are getting 1. On the other hand, if we treat yi is equal to minus 1, then minus 1 times w transpose x is equal to minus 1. So this will be minus 1 times minus 1 because this particular line has this property of -1 also, right? So this particular line will have this. So in this case, minus into minus, that's plus, so 1. So no matter whatever you do, you will always get +1. So this is the direct application of the practical machine learning using the core machine learning concept. However, you just need to remember that for any support vector, it will always give us this 1. This is the core property of a support. Now this completes the question number 185. Now let's move on to our next question. So our next question is question number 186, and it asks for code. What will be the value of print k neighbors x test 0 to 1? So 0 to 1 is basically a particular sample, and number of neighbors that we are going to take is 4. So 4 neighbors will determine what will be the next particular point class. Okay, and what you need to know here is that what k neighbors actually does. So in KNN you have multiple attributes, methods, but k neighbor attribute and neighbor attribute are little bit different. Neighbor attribute directly gives you the neighbors index. However, k neighbors attribute has a very special property that it will give you the index of the neighbor, okay, that particular location you can say in some sense, and it will also give you distance of that particular test point with respect to your training data. So y1, x2, y2, x3, y3, and x4, y5, as we have only 4 neighbors, right? So that's why it will always give you this. So it will contain this thing and this thing. So just make sure that you understand this thing, and then if you see the options, you can also get it from there. So this is done by n neighbors or neighbors. Okay, so this is wrong. It will present the distance of the point from all training points. This is also wrong because that's distance underscore, or maybe different parameters can also be used. On the other hand, it will print the distance and the index of the n neighbors in trainings. And since we are saying that we have n neighbors equal 4, that's why I'm plotting this for the test point, and we are saying that it is respect to test point as I have showed you earlier, right? So this is the thing. Any other options? Let's see. Yeah, it will throw an error. No, it will not throw an error because this particular property exists. So this is the option. Now let's move on to the next question. Our next question is question number 187, and it says which of these may not help you in handling overfitting in the decision trees. Now for this you need to understand what a decision tree is. Okay, so again we are going to look at some of the few concepts from the decision tree, and then based on that we will solve this particular question. So say you have a feature matrix f1, f2, f3, f4, f5. Now based on this you want to predict something. So what you can do, you can ask questions like if f1 is greater than some threshold, say 0.3, then split based on that, and then you have some values here. So this is called a root node, or this is where your first particular feature can be there. This is called our child node, and say this we are not going to split, we are going to end it here. So this is called leaf. Okay, and that's where these 4 parameters will come in. So that's why I'm telling you this. So let's say you got some value. Now we will ask f2 is greater than 0.5. If that is the case, then true here, false. Okay, let's say here we got some value, yeah, true, so false, we end here only, that yes, this is the answer, so no problem. But let's say if this is the case, then f3 less than some value, say x, then again split. So something like that. And once you have used all these particular features and you have get some good understanding, you will get a full grown tree, which is usually not a good practice because it will learn your training data so well that it will cause issue while predicting your test data. So in that particular case, you need to kind of remove some unnecessary child nodes or leaf. Okay, so that's the basic idea, and this particular removing thing is called pruning, by the way. Okay, and this is done after the fully grown tree or maybe before fully grown tree, and CCP alpha is the parameter which defines this in your scikit-learn implementation. Okay, once you have understood this particular thing, now let's move on to our first question, which is increasing the value of min samples. So minimum sample split basically means how many samples should satisfy the condition, say f1 greater than 0. So first sample how many satisfy, second sample how many satisfy. So as you improve the samples, you will get a better generalization, and you will be sure, like for example you can say that if you are choosing a particular cert for yourself, but if someone also helps, say 5 people say yeah this is good, then then you get more confident, right? So in that particular case, you are generalizing well. So in this sense, you can say that yes, increasing minimum sample split can handle overfitting. So this is wrong because it says not. Okay, increasing value of pruning parameter. So as I said, pruning parameter prunes the extra leaves and nodes. So if you increase that particular pruning parameter value, it kind of threshold the value. So threshold value means that if certain value is reached, then only we will do it. So if we increase this pruning parameter value, then our tree will not go in depth because more frequently it will be removed from the decision tree itself. So again, it will help in overfitting the decision tree. Next is increasing the value of minimum samples leaf. So minimum samples leaf, as I showed you earlier, right? So here, if we are not growing anything, we are ending it here then only. So this is called a leaf node, and it simply says you should have minimum number of samples. Again, same fact that it will generalize better. So end of the day, this will also help you to fix the overfitting. So again, this is wrong. However, increasing the depth of the tree, as I showed you earlier, that clone tree is not a good option. So this particular option gets marked as right because this particular thing will overfit your data, and we don't want that particular thing, right? So this particular thing ends here, and this marks the completion of this particular question. Now let's move on to our next question. So question number 188 says, in a bagging classifier or a bagging regressor, the base parameter can be. So before understanding what is the answer, let's look at what bagging actually refers to. Okay, so say I have a very large data set, okay, which have multiple features, and I want to predict the model. So what I can do is I can create a smaller models, say this, which will have my data set sample 1. So DS1, DS2, DS3 and DS4, and D is always greater than DS1. So that means DS1 will always be lesser than D because it is a sample of that particular data set, right? So it is here. Now based on this, our model is trained. Here we have 4 models, and whenever this particular model will be used to predict, so since there are many models, obviously some may work, some may not work, but as they aggregate, they will work better than your base model, or in most of the cases generalize well than a linear model, right? So you get your prediction in this. Now this is the core idea behind bagging. Again, I use some extra sample things and everything, but there are more implementation details into that. I will refer to a link in the description. You can refer to that. And in case of classifier, you just add a threshold value and pass it to some threshold function like sigmoid or something like that, and you will just get an output where if the threshold is greater than say 0.95, then your class is 1, else your class is 0. This is for binary classification. Multi-class, again, you have 1 versus rest classifier and everything like that. But yes, that's the base thing. And what it does, it takes all these as a estimators or predictors. Okay, it can take any value, like it can use linear model also, it can use decision tree also, it can use random forest XGBoost, anything it can use. No problem with that, because ultimately it is using a sample of data, it is not using the whole data, so it will generalize well at the end. So here the base sample estimator can have any predictor value. It doesn't depends on any type of model like decision tree predictor only, linear model predictor only, or support vector predictor only. Okay, so with this we have come to an end of this particular question. Now let's move on to the next question. So the next question is question number 189, and it asks for, you are working for a classification problem using sklearn.ensemble.random forest classifier. After training the model, you want to evaluate its performance on test data. Which of the following method can be used to obtain the predicted class probabilities for the test sample? So here the key term to identify is that you have probabilities, and another is that random forest classifier is a classifier algorithm. So for classifier you have 2 methods: predict, which simply gives you the prediction, that is any class you want, or there is another parameter called predict proba, and proba basically gives you an array which holds all the probabilities for different classes, and highest probability will be taken. For example, if it is 0.3, 0.5 and 0.7 for 3 classes, then 0.7 is the highest, so it will be taken. So this 0, 1, 2, say class 2 will be the output, and that will be directly fed to the predict function in the background, and it will predict that particular value directly rather than giving you this probability. So that's particular question asked for what is the predicted class probabilities for the test sample. So test sample will have other probabilities also, not one single value. So in that case you have to use predict proba. Okay, predict is wrong as we saw, predict proba. Okay, decision function no, and score. Score basically is a metric, it is not for the probability, right? So this is wrong. So this marks the completion of this particular question. Next, move on to next question. Now we are in our question number 190, and this question again asks for F1 score, most suitable evaluation metrics, where it is, right? right? So in this particular case, F1 score can be most suitable for unbalanced data as well as if focused on a particular class, right? So in that case, let's look. So there are 10,000 images, each contains cat or dog. Exactly 500 contains cats and other contains dogs. Your task is to train a binary classifier. So you can see that we have only 500 cat and remaining 9,500 as dogs, right? So there is a high unbalance, right? So for there, it is very important that we use F1 score as a metric rather than using accuracy, okay? Because F1 combines precision and recall, and that those are very good getting the most out of a classification model. Now train a binary classifier to detect if MRI image contains cryogenic cells or not a number. Number of true positives are 2%. Again, this is fixated at true positive only. We are more focused on getting the true positives. So again, we have to use F1 score as I showed you earlier, right? For a particular class, it is focusing. Now predicting if chest X-ray belongs to a male patient or a female patient. There are nearly equal number of samples. This is equal number of samples. So again, accuracy, precision, anything can be used. Based on student senior secondary marks and other features, predicting if we will fail in a particular subject. The exam clearing rate is 98.23%. If that is the case, then we are mostly predicting if he will fail the particular exam. So we are more focused on true negatives that he will fail, right? So again, we are more focused. So that's why again we can use F1. So always remember this particular logic that F1 score can be used for these particular cases. Okay. So with this, we have come to end to this question. Let's move on to the next question. Next question is question number 199. Again, I'm going to skip this particular question. Actually, we have already covered this one in our previous video. You can refer to that. But just understand the basic idea that log loss will be for our logistic classifier model. And whenever we have a perceptron, then this loss will be actually perceptron. And for any SVM model, we will have this hinge loss, and hinge loss looks something like this. So anything that is after 0, that is negative value, will be 0, and another will, all the probability is still 1. Okay. So I hope that you understood. Now let's move to the next question. Next question is question number 192, and it says which of the following option is true? Distance between data point varies when we change the n neighbors parameter in neighbors classifier. No, that's wrong, because data points can never be changed in a k-nearest classifier. The distance from the test data point can vary based on the n neighbors. However, k-neighbors classifier model couldn't able to predict the labels for the sample outside training dataset because it does not learn from dataset. That's wrong, because k-nearest neighbors classifier learns from the dataset about the clusters in some sense, because it learns that particular mapping, that if that particular thing is within this particular range for some neighbors, then obviously this will belong to this particular class. Next one is little ambiguous, but it is actually right, because it is min-max scalar, which is scaling, right? And as we have seen the previous case of SVM also, k-nearest classifier also use a distance metric, right? And when it uses distance metrics, then obviously if you have a point of 10,000, 40 and 30, 40, then this is a very huge gap, right? And model may prefer this one or may prefer this one based on the metric. So in that case, it might happen that this will choose wrong. So in that case, you need to use min-max scalar so that your values remain in the range of 0 to 1, so that this value and this value can actually be understood very easily by model. Okay, so that's why it can impact the k-neighbors classification accuracy score. In fact, if you do this, accuracy increases. Now this one is very ambiguous, and this might be an option which many of people can take, because k-neighbors classifier help in outlier detection, but this is not the case if you change the value of n. So had it been n is fixed, and n basically refers to n neighbors, okay? If that is the case, then yes, this is right. But if it is not the case, that n is not fixed, then for different variations of n, you will have different values, and then it might be wrong that you have outlier detection. A simple example can be, let's say I have 3 data points, x and x, and I have a 4th point here, and another class I have is this, and this. Now, if I set my n is equal to 4, so nearest to this are these, right? So in that case, this point gets classified as this, but it might be the case that this point actually belongs to this particular. So this is kind of outlier that you can have. So in that sense, it is not good for outlier detection in this particular case. Okay, so this marks the end of this particular question. Now let's move on to the next one. So next question is question number 193, and again this is a question from SVM. It says which of the following values of C can overfit the SVM classifier model for inseparable data. Again, I will be skipping this particular question because we have already covered this one in our previous video. You can refer to that. I will be giving link in the description. But to just make sure that you understand, the C value will control the margin width and the error rate. So if you have some data points here, then you allow for errors. However, if your margin looks something like this, which is very small, then you don't allow for errors and your margin is very low. So if this is a very higher value, that means that you are allowing model for lot of errors. So means basically model is actually learning very good on trained data, but when it moves on to the test data, it will perform very poor. So that will be your overfit case. Okay, so let's move on to the next question. So this is question number 194, and it asks for this particular thing. In this question, you are asked to find the shape 1, that means the column of X, and X is nothing but our corpus matrix or Hashing vectorizer matrix. Okay, and the vectorizer is Hashing vectorizer, which has n features equal to 12, lowercase is equal to 12, and your corpus is this particular data, and you are using Hashing vectorizer, right? So the main focus here is not to worry about the Hashing vectorizer, just focus on how many features it is going to use. So Hashing vectorizer will hash your feature and it will create an array and something, but due to this n underscore features, you will only select 12 features out of all the features. So in that case, this will be our column, right? So column will be how many? 12. So this is the answer. This is just to trick you rather than focusing on the main parameter. If you focus on this, you are going to have an issue, and you can see that answer is 12. Okay, so with this we have completed this particular question. Now let's move on to the next question. So next question is question number 195, and in this particular question you are asked what are the different parameter combinations which will be tried in grid search CV. Basically you need to focus on this particular thing, that there are two dictionaries. So based on this you are going to answer the thing, and in general when you have two dictionaries, so you are going to combine them in multiplicative manner. However, if there is another extra dictionary, you are going to add it. So how many values for this we will be getting, that if we have to multiply with how many values we are getting for this, and then we are going to add this particular. Okay, so let's check how many values we are getting. So 1 into 1, 5, 7, 10, 2, 5, 8, and then for this we have 1, 4, 7, 10, and more, not. So how many features we are getting? 1, 2, 3, 4, 5, 5, 8 plus 15 plus 4 to 9. Let's see if that is our error or not. Indeed. And so this marks the end of this particular question. Now let's move on to the next question. Now we are in our question number 196, and it asks for what is the most expected output for the given code below, and this is your code and you have multiple values, and right. Let's look at the options also. Now at the first glance you will see that there are values 2, 3, right? And you will think that yes, these options are like we have to calculate, or how we are going to calculate. This is a very tough question, but it is actually not a tough question. Here you have to focus on the keyword most expected. That means that you are even not sure that this will be your answer, right? So you don't have to calculate in this. You have to just understand few parameters and then you have to work along with. Okay, again, decision tree is there, so we will use the decision tree as our starting point. We will not focus on this thing. So here we have one parameter CCP alpha and CCP alpha. So they are comparing it, and the reason that I'm saying that it is comparing it because they have same random state. So every time they will generate the same thing. And now first one they will generate the score, and second one will also generate the score. Apart from that, first one will generate the depth and second one will also generate the depth. Okay, and if you remember when I was explaining decision tree few sessions back, I mentioned about pruning, and the same question is here. CCP alpha, if you remember, I told about the parameter, right? So for CCP alpha, that means this is a threshold value. So whenever decision will cross this particular threshold, then we will remove that thing, right? So 0.1 is less than 0.1. So this will give us a good model. This will give us a little less good model, and it is because it is directly related to the depth of the tree, how depth our tree is going. So in this case, the depth will not go that much, give us a generalized model, and in this case it will go much. Okay, so based on this particular value will be high, less, high, less. Let's look at the options. First one, as you can see, it is high. Okay, this is less. Okay, but this is less, so this is wrong. This is less, so this is wrong. Now third option, this is high, this is high, this is high, and this is less. This is again low. So this was a little bit tricky question, but yes, this is the reason I liked this particular question a lot in this particular paper. Okay, I hope that you understood this thing. If you are not sure about what I am doing here, just refer to any documentation. You will get a good idea, or maybe some other YouTube video. I will give a link to the description. You can refer that. Okay. Again guys, question number 197. This is again a very good question regarding decision tree, and obviously you should know about min sample split, min sample leaf, because this is what will help you to understand this particular question. Obviously we will not be going into the detail of this particular thing of decision tree classifier, but I will give you a simple method if it comes, how you will handle it. Okay, so here if you see, we have min samples split is 8 and min samples leaf is equal to 5. Okay, so it simply means that your all the samples which will be in your split should be minimum 8, and when you will split, after that you will have left child node and right child node. By the way, if you are not sure what left child and right child is, it is simply this. So you have this root node where you should have this minimum as 8, and this is left child, this is right child. So whenever this is true, it is left child, and when it will false, the right child. Okay, so in this particular case, your this and this should minimum have 5 samples each, or more than 5 will also do. So based on this, you will solve this particular question. So I am calling this particular root node samples as N and this as LC and RC. So based on this, we will solve the question. So first option is number of samples at root node 5. Again, this directly fails here because minimum we should have 8. So this is wrong. Number of samples node 10. Yes, this passes, that N is greater than 8. If you split, triple 5 samples. So minimum 5 is there. So LC is equal to 5, and left child, and 5 samples in right child. So right child also has 5. So this passes. Now number of samples at node 15. So again this passes and greater than 8. If you split, it will result in 9 samples. So LC is 9 and RC is 6. So left child is 9 samples, again greater than 5, and this again greater than. So this passes. Now let's move on to this option. Why it is wrong? The number of samples at node N is equal to 8. So this passes, and greater than 8, right? So it is 8. So N minimum 8. So N greater than equal to 8. If you split, 5 samples in the left child. So this also passes, greater than equal to 5, but this fails because it says 3 samples in right child, right? So 3 samples in right child means N less than 5. So this fails our condition that RC should be minimum 5, right? So this is how you will handle this particular question, or just an idea. I also explained you the theory behind it. So I hope that you understood this particular thing. The most important thing here is that you should practice and make sure that you check out the documentation also for updated details. So guys, with this, we have come to an end of this particular PYQ solving session, and I hope that you found it very useful. I have tried to include the theory, the solution, and logic tips that I used to solve this particular paper. So I just showed you my way of doing things. You are always welcome to share it with others so that others also get benefit. And please ask your queries in comments, or just let me know that you already understood all the things by commenting understood in the comment section. And if you're liking this video and want more of it, please subscribe to the channel and give a thumbs up. So with this, I will meet you in another video. Till then, bye bye.